In this video, we're going to have a look at how we can calculate Kc if we've been given the concentrations at equilibrium. So this is the most straightforward type because we're going to be given the numbers we need. We've just got to be able to come up with the expression for Kc and put the numbers in. So your first job is to write an expression for the Kc for this reaction. So pause the video and try to write an expression. So there we go, we've got products over reactants raised to the power of their stoichiometric coefficients. And I'm going to work out its units as well, so can you work out the units? And we can see that because we've got equal number of moles on both sides of our chemical equation, we've got equal number of concentration terms on the top and the bottom of our fraction, then there will be no units. All we need to do now is put in these values. These already are the equilibrium concentrations that we've been given in the question, so we just need to put them in. So I'm just going to use my calculator. So I'm going to write across the top, I'm going to put the hydrogen, which is 0.140, multiply it by the iodine, 0.040, and divide by the hydrogen iodide, but remember that that number needs to be squared. So you want to plug those into your calculator, being careful with any kind of rules with your division. It's helpful to use that fraction button on your calculator. Now when I've plugged that into my calculator, the calculator display is actually reading 0.054685, but because all these values have been given to three significant figures, 1, 2, 3, 1, we're not counting that 0, so 1, 2, 3 from the first number, and 1, 2, 3, then we're going to go with three significant figures. So we've got three significant figures, 0.0547. So let's have a go at another one. We've got another expression, so pause the video again, see if you can put these values in and work out an answer and give it to the appropriate number of significant figures and with the units. So there you go, that's what we should have seen. You should be looking at working out your units, noticing that you need to give your answer to two significant figures because we've got 1, 2, 1, 2, 1, 2 significant figures in the question, and also giving it with the correct units. So we've got ourselves another example here. Again, pause the video and have a go. Now what you might have spotted if you've been watching carefully here is that these are not concentrations. And so the first thing I'm going to have to do before I put them into this expression is turn them into concentrations. So I'm going to find my concentration of PCl5. Now remember that concentration is moles over volume in decimeters cubed. So this volume here, this volume is 200 centimeters cubed. I'm going to need that in decimeters cubed. So I'm going to take my 0.2 moles and divide it by 200, but I need to convert to decimeters cubed, which is a factor of 1,000. And so I'm going to end up with a concentration of PCl5 of 1, and I'm going to repeat that for PCl3. So I'm going to get my 0.0410 and divide it by 200 times 10 to the minus 3, and that's going to come out to be 0.205. And if you notice that the moles of Cl2 are the same, so the concentration is going to also be 0.0205. So I can put those into the expression. So I've got 0.205 multiplied by 0.205, and I can divide that by 1 because that's the concentration of PCl5. Put that onto your calculator, and your calculator should give you 0.04. Sorry about that, 0.0420. So check your units, you've got them here, moles per decimeter cubed, you've got your value given to three significant figures in this case, so you can put your units on the end. I've given that to 3 sig fig. So there's one more on the bottom of this page for you to have a go at. Have a look. We've got volume V this time, and we've got moles. This time we haven't been given the volume, but we've got just a V in there. What we're going to do with that? Now if I put my numbers into my Kc expression, what you can see there is I've got these V's and they're kind of in the way because I can't put those on my calculator. But if you notice quite carefully, we worked out there was no units. And what you can see is if you were to expand this, we've got V squared on the top of our expression and we've got a V squared on the bottom. These V's are going to cancel out, just like the units cancel to give no units. If there are no units, then the volumes are also going to cancel out. And so we can rewrite our Kc as just 1.94 squared over 0.38 times 0.19. So go ahead and calculate the value for Kc for this expression. So there you go, I've got 52, I've given it to two significant figures, I've got no units. That's our value. So what we can notice about this kind of example is when there are the same number of moles on each side of our equilibrium expression, so here we had 2 moles on the left and 2 moles on the right, when there are the same number of moles, then our volume cancels. So moles can be used to calculate Kc. Now this is only true when there are the same number of moles on each side of the expression. And also that our units cancel, so Kc has no units. So when there are the same number of terms on the left and the right, on the top and the bottom, units cancel and volumes cancel. So we can use that to help us answer some other questions.